discriminant could be positive, negative, or zero, right?
Right.
So if the discriminant is positive, what kind of solutions do you have?
I guess 2 real
Yeah,
solutions.
you get 2 real solutions. Okay. If you have a negative discriminant,
You imagine. Well, I guess you get 2 complex.
two complex solutions. Is it possible that those solutions could be purely imaginary?
Yes.
How?
Because if they're both negative, you're still going to have your eyes, right? Your eyes aren't going to cancel.
Yeah. But the only way you have purely imaginary is if gamma is 0.
Oh yeah.
Because gamma over 2m is going to give you an e to the negative gamma over 2m times t, right?
Right.
So when you work it out, you're going to have a real part multiplied by an imaginary part, right?
Right.
Or, you know, you're going to have an exponential, a decreasing exponential from this, and sines and cosines from the imaginary part of lambda, right?
Right.
And we're familiar with this. Well, what's that mean in the real world? Well, what would it mean for gamma to be 0?
I guess that would mean that your
Drag force
drag
would be
force
0.
would have to be 0.
The what?
The drag force would be 0.
Yeah, you got no drag, or negligible drag, okay? So if you got no drag, then you just have what? Well, that means this force isn't there, and this is the only one, and that gives you simple harmonic motion, right? So in the context of what we know about simple harmonic motion, we know that the equation would just be this plus this equals 0, which would give you just the imaginary solution, which gives you sines and cosines. So you have some sine function, okay? That's probably some phase angle that, you know, the general solution will have a coefficient of the sine function and a phase angle. And the angular frequency will be this. Of course, if gamma is 0, this gets really simple. But this just reduces to your solution where you get a sine of omega t plus a phase angle, right? And we're familiar with that. Okay, so discriminant 0. You would have a repeated real solution, which we dealt with last time, where you slap that t in front of the one solution.
Right.
Now we're going to discuss reduction of order, but right now we're just doing quick and dirty so you can deal with all 3 issues, right? And reduction of order is unnecessary in the case where you have constant coefficients. If you have non-constant coefficients and you get one solution, you can use this thing called reduction of order to get other solutions, and it's not always slap a t in front of it. Okay? So we want to deal with that, but not right now. Okay, so we have these 3 possible cases. And 0 discriminant means that gamma and k and m work together, okay, to give you 0 here. Okay, that's a very specific case. Okay, if you know m and k, then you know what gamma is going to give you 0, right? If you know gamma and m, then you know what k is going to give you 0. If you know any 2 of gamma, m, and k, you can figure out what's going to give you 0, right? Okay, well, that corresponds to what we call critically damped. And then you have overdamped and underdamped. And those are the names you put on these 3. But let's just work out the arithmetic then and see what the solutions look like.